as you might have seen, we have a rather long title, but I think it's very explanatory. So CLI say DIY, crafting Python-based dev tools in a DevOps vacuum. You'll see what it means a little bit later. But let us introduce ourselves. So my name is Liubov Burtseva.
I am Uri.
And we are both backend engineers at Valorant company. Okay. So, what is this talk about, you might ask? We're gonna share some, showcase, basically, our Python-based project, how we improved our dev experience by moving away from bash scripts to 100% based Python tool that touches all infrastructure-related things that we have, including deployment, integrations, monitoring, and more. And also, of course, I guess that's the most important part of the talk, we'll share the lessons that we learned from the process of migration and from the process of building itself. And important disclaimer, it's sad, I know, but the tool we will talk about is not an open source yet. Maybe it will be one day. So our main goal is not to kind of promote something, but just to share our true experience.
So, who we are as a company. Valorant is a SaaS company in the transportation management field. Basically, this means that our customers are toll road operators. They pay us to monitor the road, to alert on dangerous situations, and basically to help them prevent accidents on the road and maximize flow, both for safety and for money. As far as our architecture and what it includes, basically we have dozens of microservices across our teams. We use Kafka to communicate between them and send messages, including Kafka streams. All of the backend is Python 100%. That includes our machine vision algorithms, data science, pure backend tasks, and so forth. And we deploy very frequently. Relatively speaking, every week has a deployment to production for all clients.
Okay, but what do we need from our toolkit to be? Okay, what is the most common day-to-day use case? Like, what do we use daily as developers? Of course, we want to interact with AWS. Everything, scaling, deployment, restarts, anything, you name it. We want an easy way to authenticate to all the things that we use, some private Python packages, Docker, and stuff. We work with Kafka, so we want some easy ways to work with it, maybe to get access to it easier. And of course, it's last but not least, right? We all work with Jira, and I don't know, I personally have mixed feelings about it, but still have to work with it. So it's nice to have a simple tool to just start a ticket, add repo, anything that you do with Jira. Also, we care about automation. We don't want to do everything manually, right? So for our QA team, especially, I promise them I mentioned them. We want to enable them to make connections to all the data sources, to everything they need to validate, basically. We might want to do database synchronization between prod and staging. We want to ensure release management, what it is to create tags, to publish Docker images when, for example, we merge into them. Of course, we deploy weekly, and production deployments can be risky and tricky, and we want some automatic way that will check all cross-service dependencies, as we are a microservice company. And yeah, again, it's last but not least, right? It improves our life as developers. When you have an open pull request or are requested to do something, it's nice to get a notification to Slack.
So, what we had before, the existing problematic solution. Basically, we had a suite of tools that was completely bash-based with everything that comes with that. We had integrations for all the stuff we mentioned before and a couple more. which is for Docker, for our different databases, for Jira, for GitHub, etc. We had a monolithic, big code that was entirely bash-based, was very hard to extend, was very hard to debug, was very hard to understand. And basically the knowledge was spread very concentrated on very few individuals inside the company that held the entire knowledge of how the tool works and what to do when it breaks down.
Okay. So, the ultimate question is, we already have a tool. Why do we want to build one? Like, to build or not to build? Like, why invest time and effort to build a new one when we have existing one? Or maybe we could all use something that already is in the market, right? That's what DevOps do, I'm told. But for several reasons, we decided to develop a new tool. So first of all, we are a small tech team with no dedicated DevOps. We have a complex infrastructure that we need to maintain somehow. And we learned our lessons from the previous tool. Everyone should be like, almost everyone, you know, everyone who wants should be able to read, maintain, and extend it. It shouldn't be, you know, concentrated in like hands of one person. Also, like previously we had a CLI tool, okay, so it's kind of, you know, same functionality, but from every microservice, and especially like it was painful for our QA department, we had to kind of connect to everything, and then they had to build like everything from scratch every time. So it would be nice to have a library just for that, at least, and maybe for something more. And of course, our company, like, I'm not sure whether we can call ourselves startup anymore, because we are rapidly growing and we experience scalability issues. Also in terms of infrastructures, we have to have even more AWS accounts, more roles, so to say.
So the solution is Machina. Not this Machina, but this Machina. Thank you. For those of you who don't know, Machina also means car in Russian.
Hello.
So, Machina is a CI tool and a package. It is meant to be as simple as possible, as straightforward as possible, like Machina's music, sorry. This is one example of the ways you can use it as a CLI tool. You can see integrations for S3, for ECR, for GitHub, for the various external integrations we talked about before. We'll dive into some of them deeper in a few seconds. And this is an example of usage inside one of our services as a package. You can see it imported. You can see some models in the first rows being imported for authentication against AWS in this case. That's it.
Okay, development principles. Of course, we wanted something, you know, best practices, but still kind of, you know, time to market, time to developers wise. So yeah, we tried to implement everything as good as possible. So of course we use OOP and domain-driven development, which is trendy, like any other our microservice. So the idea here is like our developers, we talked about the maintainability, right? So like the idea is when you open this tool, it wouldn't look like something alien. It should look something familiar, like any other microservice have the same structure, have the, like, you know, familiar patterns. We need to test it because like, it touches very sensitive areas of our developers' lives. It should be independent from local machine when needed, so you are not bound to, like, you know, versions of the libraries installed at your local machine. You can play with them, not everywhere, but like when needed, without any exaggerations. It should be open for extensions. We talked about that a lot already, I feel. And it should be compatible with different operating systems, because our developers use like macOS, Windows, Linux, like the whole zoo of different OSs. And here we see our kind of attempt on DDD, and that how Machina's architecture, like, you know, big picture looks like. So we use Typer. Some of them may be familiar with that. That's a library to build CLI tools. So it kind of triggers everything. We have a lot of services that starts the process. As a unit of work, we use context class of Typer. So we pass all the parameters needed for a connection to for the adapters for repositories. You'll see the example a little bit later. So on adapters layer, we have like a lot of repositories, and in domain we have entities and value objects. And that is actually, I know it's huge. They told us to make it bigger. Sorry, maybe a little bit too much, but at least you definitely can see it. So we have machine context object that is a class that has all information about information for repositories to work with, like all connection details, for example. Also, you might see dry run in the very top. We use that, actually we talked about testing, we use that for running, like simulating the runs of machine. We have a scheduled task running on scheduled workflows run on GitHub. And when we put it to false, we can just safely run that, knowing that nothing new next to will be created. Okay, and here is a adapters layer, a little bit with more details. What's interesting here is, like, you can see that we have a lot of different integrations. We have more, they just didn't fit in the diagram. But important thing here is how we use DynamicDB to, like, we have external storage to save state of machines. So, like, for example, server goes down, it happened to everyone, I guess. We still have state saved, because sometimes, especially if we talk about, like, say, deployments, it can be risky to just have it only in memory. Okay.
So we keep talking about how easy it is to use, but let's dive into one example of how exactly it makes our lives as devs easier. In this case, we'll be looking at a real-life example of us adding Grafana integrations. For those of you who don't know, Grafana is a tool for graphing different metrics and states of your system. The principles we had were that it would be easy to use, easier than GrafanaLib, which is kind of not friendly to devs, and that we will have a single command that we can run from our service to deploy all the dashboards we need, all our standard dashboards for performance and for state, with one single command. So how are we going to achieve that? Each and every repo we have, each service has an iac.py file, infrastructure as code, which defines all the different classes, methods, objects that, in this case, Grafana needs to deploy. Machina dynamically loads these objects and uses them as Python code instead of as a config file that has to be proprietary and messy to use.
Okay, let's draw some sketch and get to the code already, right? So that's kind of design. So for, again, who works with Grafana? Who has the idea what Grafana is? Everyone, almost, thank you. That's amazing. So you know the panels that are basically building bricks. You can organize, you don't have to, but it's better always to organize them in, like, kind of rows. Also, like, for us, you know, service, we want to pass some metadata, like service name at least, right? Maybe GitHub repository or something else. And let's say for now, we can, like, for Grafana, we can pull metrics, I think, from almost everywhere you want. And in this example, we'll be pulling them from CloudWatch. So let's say we already have some metrics set up, some custom metrics set up in CloudWatch, which is AWS monitoring system, kind of. Okay, so again, too huge, sorry. That is, like, the idea how it can potentially look like in a service. Spoiler, we implemented that, so it works. that is example of IAC.py file from one of our normal microservices, not like infrastructure tools, just regular microservice. It's a web service, so we work in rows domain, so that's one of our sources, and we need to be sure that it in this, for example, I'm saying example too much. It runs successfully or not successfully. We want to be we want to have this information. Here we just use basically kind of mixture of Grafana lib. If you worked with Grafana, you probably touched Grafana lib, which is a library for interacting with Grafana from Python. That's not ideal library. We promise to share experience. That's not ideal library. It's a little bit out of date, but that's the best option we have. So here we specify targets. Online, for example, 36 and 43, you see the names of our metrics set up in CloudWatch. And the rest is just metadata. Statistics is also needed for CloudWatch. You can select average or max or minimal, whatever you want. Okay. We need to also, that's the same IAC.py file. We basically, the idea of this file is it just creates several classes that machine will just load and turn into, in this case, gigantic JSON blob under the hood to send to Grafana. So here, for example, we want to create panels for waste staging. We didn't put all the examples in the slide just to save some time, but you got the idea. For example, we have here 3 panels that we add to the custom monitoring row. This is a class imported from Machina, so just familiar to it. And then we just pass it to domain. What is domain? Is basically a service with some metadata. And we just send custom monitoring rows.
Continuing on with the code, what we're seeing here is the adapter that we use to connect the Grafana externally.
That's from Machina itself, just to note.
Very basic data for the URL we have to reach for the server to upload the dashboard in this case, and authentication info. Here you can see the very straightforward code. Basically, we just construct our response from the different parameters and check for errors, post it to Grafana. Very straightforward and basic, but it is abstracted away for all of the devs. Now that we've seen sort of the interface and the architecture, we can dive into the logic of the service itself. Nothing too fancy. Yeah, so here we can see the basically the logic of the code itself, the service layer. One of the most important objects you'll see here is the context, which is basically what we saw before, the Machina context, which holds all the info basically needed to act as a unit of work and interact with the external services, Grafana in this case. And domain, as Luba mentioned before, is basically the name of the service, the accounts and different environments we want to deploy to or we want to create graphs to, and some metadata. Here we can see the creation of the panels. I'll dive into the function on row, what is it, 284, I think, hard to tell from here, but it handles most of the logic of constructing the panels themselves using Grafana lib, and then we just, after parsing each and every record of the domain records that we saw before, load it up to the dashboard, nice and easy. Here we can see the domain class we talked about before. It holds the default accounts that we use for services, as well as custom rows we want to add to the graph as a panel.
Okay.
One more thing, this is the method from before that handles creating the panels themselves. Some of the logic here is very specific and not too interesting, but basically we just iterate over our records which define the different names and metrics we want to create and add them to our list of panels we return at the end.
Amazing. Let's update our entry point. Remember, DDD is like a repository service layer entry point. So on the very top, on line 36 here, you can see a decorator that basically like tells typer that when you see Grafana in command line, write this. What we do here is we basically tell it to look for ic.py file in the directory that we pass, so that we are at currently. So like it is assumed that this file should be on the very root of your service. Then we load that as a module. That's important. It's not some familiar configuration that you probably are familiar with, like JSON, that was the main theme of the previous talk, or like YAML or whatever. It's a runnable Python file. So all the initialization of like instances of classes, they are there. Then we find instances of domain. That is basically, you just saw the domain object. That is like our service, basically. Then we connect to cluster because we are pulling the data from CloudWatch, which is part of AWS. So we need to establish a connection. You can connect to other cloud that you use or other things. Then we run the instantiated graphanizer that was from service layer, and then we run this to methods. First one is from service layer. We need to parse it, sort of, turn it into the dashboard, and then we need to just send it to Grafana easy upload dashboard. So, results.
What are the results of Machina, that is? Basically, as far as time and effort goes, it took about 4 weeks to complete the first version of Machina, which had all the basic integrations we defined as minimum, which was deployment, Jira, and some others. As far as getting accustomed to it, but like the dev team getting accustomed to the new tool was very quick and easy, and within a few weeks, everybody were using Machina and not missing the previous solution anymore.
Maybe a little bit missing.
Maybe a little bit, yeah. And now, basically, we have a tool which is not this sort of black box or bash tool that no one has the motivation to check and fix. And we have Python code that everybody can get into, extend, contribute, and so on. As far as some technical lessons from how we implemented it, so basically we probably should have used an ORM and not pure SQL. It's better in the scenarios that we use to more efficient and helps with big queries. We probably should have followed the template of the previous tool a bit less and mapped better like the needs of the dev team, followed more closely what exactly we need to achieve and not use the example too closely. And there is inevitably some feature gaps still from the previous solution. That's just something to keep in mind if you implement something similar. As a whole, was it worth it? 1,000 times yes, at least for us. Would we do it again? Again, yes. We now have the option to improve and move with the changes a lot more, and we understand what broke when it breaks, which is a big improvement. But it's important to stress that this is like not a silver bullet solution for each and every team. It's very, very specific to the way our company is constructed, and specifically having a small team with no DevOps. If you're at a big organization with a dedicated DevOps team, this is probably not the way for you.
Okay, let's give floor to our developers. We asked them about their honest opinion, and they promised us that they were honest. And it was not forced, at least I'm not aware of it. But they turned out to be pretty happy. Like, for example, this theme is coming from IOK department. Like, I mentioned QA too much probably, but they were really very against moving to a new tool at first, when like we were just discussing that, designing that. And now they're really maybe the biggest fans, which is, for me personally, was a big surprise. So, for example, next slide, please. Here, like for example, that is definitely from QA, again. So, for example, they now can just use all the authentication bits directly from machine and not bother about building them from scratch, which apparently helps them. Good for them. Another opinion is that is a centralized place. So kind of Swiss knife concept that makes works easier, apparently.
Another piece of feedback we heard a lot was abstracting away and simplifying the database migrations, which happen automatically with any deployment we do. This is something that used to be a big pain point across the team, both for our databases as well as services with difficult configuration files like Flyway and others. The deployments themselves got much faster and almost automatic. It used to be a manual process, took a long while. There was automatic functionality in the previous tool, but again, it tended to break and no one had the motivation to fix it or deep enough knowledge of the code.
So thank you. That was the last talk of the day. I hope you enjoyed it. Let's stay in touch. Reach out to us, and if you have any questions, we're here, you can come and ask them. Thank you very much.
Thank you very much.